Good morning, friends. Today we'll discuss about a global system for mobile communications and mobile computing subject. So myself is Pradeep Deshpande and I'm going to dictate the lecture on this particular topic. So initially we'll discuss what is global system for mobile communication. So it is just an acronym for Global System GSM. It signifies an extremely successful technology and barrier for mobile communication system. Uh, GSM now covers 71% of all the digital wireless market. The mobile telephone has graduated from being a status symbol to a useful appliance. People use it not only in business but also in personal life. Its principal use is for wireless telephony and messaging through SMS, that is short message service, and in many ways we can use this GSM. So this GSM has some objectives. So the some of the objectives are, the first one is it support for international roaming, that is we can move from one country to another country with a different channels. It supports for good speech quality, that is there will be not any noise. Sometimes in noisiness it can happen. uh, Third one is ability to support handheld terminals, low terminal and service cost, spectral efficiency, support for a range of new services and facilities, ISDN compatibility. These are the some of the objectives of the GSM. Now we'll discuss the timeline of GSM, that is how it evolved. GSM originally in 1982 it was established as a group special mobile. Then in 1987 they have renamed, they have added some facts into it, that is essential elements of wireless transmission. Then in 1989 it becomes ETSI Technical Committee. ETSI stands for ETSI stands for European Telecommunication Standards Institute. Then in 1990, phase 1 of GSM 900 specification, designed through 1987 through 1990, has came into the market. In 1991, the first GSM network was launched. In 1993, first roaming agreement came into effect. That is roaming in the sense moving from state to state or moving from one country to another country. In 1994, data transmission capability was launched. In 1995, phase 2 of GSM was launched. In that, fax and SMS roaming services were offered. In 2002, SMS value crosses 24 billions per year. That is 750 millions of subscribers were there in GSM communication. Now, how this GSM works? This GSM is nothing but it is a combination of FDMA and TDMA. FDMA in the sense frequency division multiple access, and TDMA means time division multiple access. And it has allocation of 50 megahertz of frequency or bandwidth in the 900 megahertz frequency, that is 890 to 915 megahertz and 935 to 960 megahertz. And these are subdivided into 124 channels, actually 125, in that one is not used. And these each channels are of carrier bandwidth of 200 kilohertz. Then using TDMA, each of the above mentioned channels, that is those 124 channels, is then further divided into 8 time slots. That is, using FDMA it is divided into 124 channels of 200 kilohertz each, and using TDMA they are again divided into 8 time slots each. So with the combination of FDMA and TDMA, a maximum of 992 channels for transmit and receive can be realized. That is nothing but 124 into 8. Now, how the frequency can be reused in GSM? To serve hundreds of thousands of users, sometimes maybe millions of users, the frequency must be reused, and this is done through cells. These cells are nothing but area to be covered by the particular mobile station, and this area is covered subdivided into radio zones or cells, though in reality these cells could be any shape. Convenient modeling purposes, these are modeled as hexagons having 6 sides. Base stations are positioned at the center of these cells. Each cell I receives a subset of frequencies FBI, called as FBI, from the total set assigned to the respective mobile network to avoid any type of co-channel interference, and two neighboring cells never use the same frequencies. There may be many number of cells and each cell has a different frequency. Now, only at a distance of d, known as frequency reuse distance, the same frequency from the set FBI can be reused. Cells with distance d from cell I can be assigned one or all the frequencies from the set FBI belonging to cell I. When moving from one cell to another cell during an ongoing conversation, an automatic channel change occurs. This phenomenon is called as handover. That is, when we move from one base station to another base station, all the information will be handled to other base station and channel will also change, and that mechanism we call it as handover or handoff mechanism. Handover maintains an active speech and data connection over cell boundaries also. The regular repetition of frequencies in cells result in clustering of cells. The clusters generated in this way can consume the whole frequency band. The size of cluster is defined by K, the number of cells in the cluster. This also defines the frequency reuse distance D. The figure in the next slide shows the example of cluster of size 4. So here we have a cluster of size 4. So you can see here this is one cluster. So whatever frequency we will have at 1 in the cell 1, whatever frequency we will be having, that particular frequency will not be there for 2, will not be there for 2, 3, 4, and these 2, 3, 4, but this 4, 1, 2 can have same frequency as 1. That is, as we discussed in the previous slide, at a distance d we can have same frequency. That is what we call frequency reuse. These all are different cells, and this group of cells are called as clusters. Now we'll see GSM system hierarchy. So here we have a initially public LAN mobile network, which is can also be called as GSM administrative region. Then we'll be having mobile switching center MSC region. Then we'll be having location area, then base station controller, different locations areas, and different base station controllers. In these base station controllers we'll be having different cells, and at the end we'll be having the MSC region again in different cell, in other cell or another way. So now we'll move with the GSM architecture. So here we have different things here. So initially we'll see the different groups here. So first we'll see about this mobile station. They are mentioned here. This is the mobile station. This mobile station can be connected to this base transceiver stations. Then these base transceiver stations are connected to base station controller. This base station controller is controlled by MSC, that is mobile switching center, and there is a GMSC that called as gateway mobile switching center. When we are moving from one MSC to another MSC, the gateway MSC is used. Then we have PLMN here, PLMN and internet, public LAN mobile network and internet. And here we'll be having ISC international switching center, that is if we are moving from or we are calling from one country to another country, then this ISC is used. Then we have a OMC here, operation and maintenance center, and this controls all the region, all the other main subsystems. We have VLR, HLR, AUC, ER, called as verifier location register, home location register, and authentication center, equipment and identity register, many other things. This whole combination can be called as GSM architecture. So guys, till now we have seen what is GSM, how the timeline of GSM was there, history of GSM, how it evolved, and some points about the GSM architecture. In the next class we will see some more different points regarding GSM. Thank you.